Hello, everyone. In this video, we're going to answer one of the most common Spark interview and production questions. Why does a join cause executor out-of-memory errors? Many people think increasing executor memory solves the problem. In reality, that's usually just treating the symptom. By the end of this video, you'll understand why joins consume so much memory, the most common reasons for executor OOM, how to identify the real root cause, and how to fix it efficiently. Let's begin. Before discussing the causes, let's understand what an executor out-of-memory error actually means. During a join, every executor receives one or more partitions to process. The executor must hold data in memory while performing operations like sorting, shuffling, or building hash tables. If the amount of data assigned to that executor exceeds the available execution memory, Spark first tries to spill intermediate data to disk. However, if the memory pressure continues to increase, or Spark cannot allocate additional memory, the executor throws an out-of-memory exception, and the task fails. So an executor OOM doesn't simply mean the cluster has insufficient memory. It usually means one executor is trying to process much more data than it can handle. Now let's see why that happens. The most common reason is data skew. Imagine joining two tables using customer ID. Most customers have a few hundred records, but one customer has millions of records. Spark partitions data using the join key. Because one key contains an enormous number of rows, almost all those rows end up in a single partition. As a result, one executor receives a huge workload, while the others remain mostly idle. That overloaded executor consumes excessive memory and eventually fails with an out-of-memory error. This is called data skew. Typical solutions include salting, adaptive query execution, or repartitioning the data. The second reason is large shuffle partitions. Suppose you're joining hundreds of gigabytes of data, but only using a small number of shuffle partitions. Each partition becomes extremely large. Since one executor processes one partition at a time, that executor now needs to hold a massive amount of data in memory. Even with a balanced data set, oversized partitions can easily exhaust executor memory. Increasing the number of shuffle partitions, or repartitioning the dataset, creates smaller tasks that are much easier to process. Another common issue is an incorrect broadcast join. Broadcast joins are very efficient when one table is genuinely small. Spark sends a copy of that small table to every executor, avoiding a shuffle. But if the table being broadcast is actually large, every executor now stores its own copy in memory. Instead of saving memory, you've multiplied memory consumption across the cluster. Always verify that the broadcast table is truly small before forcing a broadcast join. Sometimes the input data isn't the problem. The output is. Imagine customer A appears 1,000 times in one table and 2,000 times in another. When Spark joins those records, it produces 2 million matching rows for that single customer. This is called a many-to-many join explosion. Even though the input datasets seem manageable, the output becomes dramatically larger, consuming huge amounts of memory and potentially causing executor OOM. Always understand the cardinality of your join. The fifth reason is wide rows. Developers often write select star and carry every column through the join. Many of those columns may never be used later. Every unnecessary column increases the size of each row. When millions of rows are involved, that additional memory usage becomes significant. A simple optimization is to select only the columns you actually need before performing the join. Smaller rows require less memory and less network transfer. So, how do we determine which problem we're facing? The first place to look is the Spark UI. Check whether one task takes much longer than the others. Look at the shuffle read and shuffle write metrics. See whether Spark is spilling heavily to disk. Check whether executors are repeatedly failing. Next, inspect the execution plan using explain. This tells you which join strategy Spark selected. Finally, verify the partition count and check for skewed keys in your data. The important point is this: don't guess. Use Spark's metrics to identify the real bottleneck. Let's summarize the solutions. Balance partitions by repartitioning when necessary. Use broadcast joins only for genuinely small tables. Select only the required columns before joining. Cache data only when it will be reused multiple times. Choose an appropriate number of shuffle partitions based on the size of your data. And remember, increasing executor memory should usually be your last option, not your first. Most Executor OOM problems are caused by inefficient data distribution or execution strategy, rather than insufficient hardware. Let's quickly recap. If a join causes an executor out-of-memory error, think about these 5 possibilities. Data skew, large shuffle partitions, incorrect broadcast joins, exploding join output, wide rows carrying unnecessary columns. Then debug the problem using the Spark UI and the execution plan. Identify the actual cause first. Only then apply the appropriate optimization. That's how Spark engineers troubleshoot production jobs, and it's exactly what interviewers expect you to explain. Thanks for watching, and I'll see you in the next Spark Deep Dive.